Then question 5 says we have to sketch f of x and we have to sketch g of x on the same set of axes. So let's quickly write this down. This function over here is a parabola. Whenever you have x squared, that's a parabola. And whenever you have x in the power, that is an exponential function, Exponential function. So, okay, let's write down. I'm going to write my functions down, but now I'm going to write it as y is equal to negative x squared plus 4. And my other function is y is equal to 2 to the x plus 3. Okay, now to sketch a parabola, the first thing you need is the turning point. That is also the y-intercept. And to do that, we let x be 0. Then the second thing we need the x-intercepts. And we let y be 0 to get that. Then the last thing we just need to know what the shape is, Is it a smiley or is it a sad parabola? Then for the exponential doesn't have a turning point, It also doesn't have a y-intercept, but it does have an asymptote. So that's the first thing we'll find out. Number 2, x-intercepts, if you have any. So sometimes you don't have, And then number 3, we'll do a little table, okay, to plot our points. So let's start with this question. Let's quickly get our important points. So for the parabola, to get the turning point or the y-intercept, we make x 0. So y is equal to negative 0 squared plus 4. And I get my y to be 4. So that means the turning point is 0 and 4. That's the turning point and the y-intercept. Then for the x-intercept, I let y be 0. So I write my function down, but I make y 0. So negative x squared plus 4. And now I solve for x. I'm going to bring everything over. And then I'm going to do the difference of two squares, So this is x plus 2, x minus 2. So I get my x-intercepts to be negative 2 and 0 and positive 2 and 0. Okay, and then the shape. So when you look at the function, do you see here in front of x squared? That sign in front of x squared will give us the shape. If it's a minus, it's a sad face. So our parabola will look like that. That's our parabola. Okay, I think we can sketch our parabola with a turning point, So my turning point is 0 and 4. So somewhere here, that's 0 and 4. And then, so I first do turning point, then I do the shape. So the shape is sad face, So this parabola will definitely look like this. It's sad face, Then do you see here, it cuts the x-axis here and here. That's the x-intercepts. So this is negative 2, positive 2, and then here where the turning point is, this is a 4. And that's your parabola. Okay, let's do the exponential function. So for the exponential function, we need an asymptote, So our asymptote is this number over here. So our asymptote is called y is equal to 3. So that's a line. Then for the x-intercept, we let y be 0 if we have any. So let's make y 0. Bring the 3 over. Can you see we can't make the base numbers the same? So there's no solution. So here we have no solution. Okay, so no x-intercepts. And because there's no x-intercept, it's nice just to do a table. So my table, I'm only going to have 3 values. Negative 1, 0, and 1. Okay, you can choose any x values, So now I'm going to sub in the negative 1 into my function. So remember, this is my function. So first thing, I'm going to make this x negative 1 and see what I get, If I sub in negative 1, If I sub in negative 1 over here, I get this answer to be 3.5. If I make it 0, I get this whole answer to be 4. If I make this 1, I get this answer to be 5. The point I'm going to plot is this point, and this point. But before I plot, I'm going to draw in my asymptote. So my asymptote is y is equal to 3. So grade 10, if 4 is here, then 3 is there, somewhere there. Doesn't have to be according to scale. So somewhere there, there's this line called y is equal to 3. That's my asymptote. Now I'm going to plot the points. The first point is this one, -1 and 3.5. So -1 is somewhere there. -1 is here. 3.5 must be between, if this is 3 and this is 4, then 3.5 is there. Now I'm going to plot that point. -1 and 3.5 can be anywhere there. Then my next point is 0 and 4. 0 and 4 is this point over there. And then 1 and 5. So this is 1. 5 is above 4, so somewhere there. Okay, so there's my points. So my exponential function, let me just erase this to have more space. My exponential function will look something like this. So close to the asymptote, like that. That's my exponential function. And you can just put 1 point in 1 and 5. And you can even put 0 and 4 also here. 0 and 4. And that's your two graphs. So how do we mark it? Let's see. For the intercepts, so if you have your x-intercepts and your y-intercepts, so this and that, you get a mark. So if you have that, you get a mark. Then for the shape, so if you have a sad face, this is for the parabola, you get a mark. Then for the exponential, your y-intercept there, you get a mark for that y-intercept. So there. Then you get a mark for the shape that went like that. So that's a mark. And then you get a mark for the asymptote, showing the asymptote. So this is y is equal to 3. So that is also a mark. And that's how you would get 5 marks for sketching this function. The next question says 5.2, write down the coordinates of the turning point of f. So there's f. F is the parabola. Now, in the previous question, we did work that out. We had a turning point. So the turning point was 0 and 4. And that's 1 mark for you. Then the next question, 5.3 says, the graph h of x is given. So this is h of x. And this h of x is obtained by transforming f. So f was changed, and now it's this one. So f was this graph. And now h is this graph. Now they're asking, what did we do to the first one to get to the second one? Okay, you have to describe the transformation. Now let's look at the difference. You see, this is a minus, and now this is a plus. This is a plus, now this is a minus. Now, when all the signs change, you see all the signs changed. When all the signs change, we say f of x was reflected in the x-axis. So when all the signs change, our graph is reflected in the x-axis. Okay, let's look at question 6. Question 6 says the graph f of x. So the graph f of x is this one. So when x is in the denominator, like that, that's hyperbola. So that's hyperbola. And g of x, mx plus c. G of x is mx plus c. That's a straight line. They are drawn below. And then it says a is 4 and 4. D is 0 and -4. And E, they are all points on the straight line. Yeah, they are all on the straight line. That's right. Then it says B is the x-intercept of F and G. So B is the x-intercept of the straight line and the hyperbola. And then it says B and E are the points of intersection. So this and this, they are the points of intersection. And then they say AC is parallel to the y-axis. So AC is parallel to this. So that means these two lines are parallel. So Question 1, 6.1 says, determine the values of M and C. Now, M and C, they are here by the straight line. So the question is actually, find the equation of a straight line. So when you have to find the equation of a straight line, you write this down. Y is equal to mx plus c. M refers to the gradient of the line. So to get the gradient, I'm going to use this point and this point. I'm going to say the one y minus the other y over this x, that's 4, minus this x there, that's 0. Okay, put that all in the calculator, and I get my m to be 2. So far, I have y is equal to 2x plus c. So that m over there just became 2. Now to get c, I can either see it, because d is the y-intercept of the straight line. D is the y-intercept of the straight line. So if d is the y-intercept of the straight line, then c is negative 4. Y is equal to 2x minus 4. Okay, if you can't see that, you can just sub in a point. So let's sub in a point. So let's say you couldn't see that, then you can say, okay, let me sub in a point on the line. So I'm going to sub in 4 and 4. Then the y becomes 4 and the x also becomes 4. So I'm going to substitute. So this becomes 4. 2 times 4 plus c. 4, this is 8. So c is 4 minus 8. So c is negative 4. You see there I get the negative 4. So therefore, y is equal to 2x minus 4. And then if you had to answer the question, you say m was 2 and c is negative 4. Okay, and how do they mark this question? Let's quickly check. They mark this question. Gradient, you get a mark. So for working out that gradient. And then also for seeing the y-intercept. So that's why it's only 2 marks. Okay, so now that you're done with that, here by the straight line, I'm going to go right in the equation. This equation is y is equal to 2x minus 4. Okay, because I worked that out now. Let's look at the next question. Okay, my next question is, what is the range of f? So f, I'm going to write down like this. The range of a hyperbola. Range refers to y. So y is an element of a real number. This is the range, so 6.2. But y cannot be the asymptote. So remember, this is the asymptote. Y cannot be negative 2. So here, how do we get marks? In this memo, they give a mark for each, for this and for that. That's why it's 2 marks. Okay, next question is 6.3. Determine the coordinates of the points of intersection of the two graphs algebraically. So they want you to work it out, eh? So this is a point of intersection and that is a point of intersection. Now to work out a point of intersection, you just make your two graphs equal to each other. So that's the straight line. And let's write the hyperbola down. That's the hyperbola. I'm going to make them equal to each other. So I'm just going to say straight line. That y is equal to the other y. Okay? So I just make this equal to that. And I'm going to solve for x. So now it becomes algebra. So the first thing I would do is, I would get rid of this x over here. So I would get rid of this x. So I'm going to multiply every term by x. So it's this times x, this times x, this times x, and this times x. So I'm going to multiply every term by x. Let's do that. 2x times x is 2x squared. 4 times x is 4x. 4 over x, let's do it here, times x. This and this will cancel. So this is just 4. And then 2 times x is 2x. Then I'm going to get everything in standard form. So 2x squared minus 4x. Bring the 4 over. Bring the 2x over. Equal to 0. Okay, add the like terms. 2x squared. So this and this, they are like terms. I get minus 2x and then minus 4. Okay? Now I want to solve for x, So I can see there's a common factor I can take out. I can take out 2. So this is x squared minus x minus 2. And then I keep the 2 in front, and then I just factorize this, eh? So remember I told you if you have x squared, you must have two solutions. So x and x, a 2 and a 1, a minus and a plus. So I get, so this doesn't matter, eh? So I get my x to be a positive 2 or a negative 1. But remember, points of intersection, you need an x value and you need a y value. So I have this x value and this x value. So I need to sub them into one of the equations, right? So my answer was x was 2 or x was negative 1. So I'm going to take any one of the equations. I'm going to take my straight line. So this is my straight line. And then I'm just going to make my x 2, eh? So there where x is, I'm going to make it 2. And I get my y to be 0. So my first point of intersection is when x is 2, y was 0. Okay, and in my other one, I'm going to sub in negative 1. So y is equal to 2, negative 1 minus 4. So y is equal to negative 6. So if x is this, y is that. So the other point of intersection is negative 1 and negative 6. Okay, and there you work that out. Now I would go to my function and go put those points in. So this is a point of intersection and that. So I think this one is a positive x value. So this one is the 2 and the 0. So this one is 2 and 0. And this one here is negative 1 and negative 6. So I just put that on my diagram, eh? Okay, let's look at our next question. Our next question says 6.4. Determine the values of x for which g of x is greater than f of x. So where is the straight line, that's the straight line, above, so greater than means above the parabola. Okay, that's the question, eh? Where is the straight line above the parabola? So when you have two functions like this in a question, we look at the points of intersection. So this is the point of intersection, let me circle, and this is the point of intersection. I'm going to move my finger on the straight line, always on the first function, eh? So now I'm going to go from this part of the straight line up until this point. Is the straight line above or below the hyperbola? So here's the hyperbola, eh? Let's highlight the hyperbola. There's the hyperbola. Is the straight line above or below? So there it's below. So, okay, let me just do a little number line. So the x values of my points of intersection, eh? Only my x values. This is negative 1 and this was 2. That's the points of intersection. Before negative 1, the straight line is below. So I say minus for below. Then between negative 1 and 2, let's look. Between negative 1 and 2. So from here to here. So from here to there. Is the straight line above or below the hyperbola? So let's highlight the other branch. This is the hyperbola. Is it above or below? It's both above and below, eh? Just look at this line here. This line cuts it. So I'm going to do it again. From here to here, it's above this hyperbola over there. So you see this line. This line is called x is equal to 0. So I'm going to go and put another number in here. I'm going to put 0 in here. So between negative 1 and 0 there, the straight line is above the hyperbola. Then from here to here, I'm looking at this part of the hyperbola now. From here to here, it's below. And from 2 onwards, it's above this line, eh? So there it is above. Okay, so now let's look at the question. Where is the straight line above the parabola? So I'm only looking for pluses, eh? So I have a plus here and a plus there. So how do I write this answer? it is where x is between -1 and 0. So -1 and 0. Or here, it's where x is greater than 2. But because your question had an equal sign, you see that equal sign? You must also have an equal sign. So I put an equal sign here. I put an equal sign there. I don't put an equal sign there, so take it away. Why not? Because the 0, that 0, it's an asymptote. That's an asymptote. So this hyperbola has two asymptotes, eh? Y is equal to -2. That's that line over there. But then this line over here is also an asymptote. That line is called x is equal to 0. So we can't have an equal sign because the graph will never be equal to the asymptote. So that's how you do that question. A little bit tricky, but I think you can do it. Okay, and now our last question. 6.5 says, calculate the length of AC. So AC, let's highlight. AC is from here to here. Now, to get a vertical distance, we need the y values, eh? We need the y values of this point and this point. Okay, so let's look. Here we have the y values, but C, we don't have the y values. Now, the x value of C is 4. Remember, this line is perpendicular to the x-axis. So on this line, all the x values are the same. So if the x value is 4 here, the x value is 4 there. Now, C is on the hyperbola. So I'm going to write the hyperbola down. What's the equation? 4 over x minus 2. And now I'm going to sub in. Let's sub in x is 4. Because we want to know what's y when x is 4. So 4 over, now x is also 4, minus 2. So this gives me 1 minus 2. So this gives me -1. So this is -1. So to get the distance, so let's write 6.5. AC is biggest y minus smaller y. And I get 5 units. And that's how you can do that question. And that's for 3 marks, eh? And that's the function question of this paper.